All right. Hi, everyone. My name is Chelsea Bowling. Good morning, afternoon, evening, wherever you are. Happy Friday to all. Welcome to the DevSecOps automation with GitHub Advanced Security, aka GHAS. I'm your presenter today. I'm a part of the professional services team here at GitHub, and I'm an implementation engineer for Advanced Security. All right. So let me change the slide. All right, cool. So along with myself, I have my colleagues here, John Lupton, one of our lead security solutions architects on the team, and my other awesome colleague, Mario Campos, who is also an implementation engineer and who is also moderating this workshop. So we're very glad you've taken this time to be with us and to take this workshop. All right, so let's begin. Okay. So what is advanced security? Before we even dive into GitHub Advanced Security, let's discuss what DevSecOps is and the importance of it in the software development lifecycle, right? So it's pretty simple. It includes all the best practices of DevSecOps. And so DevSecOps brings security into development and operations teams to ensure that security is a top priority at every step of the software development lifecycle. So to drive down the number of vulnerabilities in production code, we should make sure that security is a part of everyone's daily work instead of testing our security concerns at the end of the process. So putting developers front and center for application security is the most effective way to shift security left and succeed against the mounting technical debt that can overwhelm even the best teams. So this means integrating security testing and controls into the daily work of development, QA, and operations. And ideally, we want to automate this process. And that's what we're going to do in this workshop, automating DevSecOps by using GHAS. All right. So as you can see in the slide, I mentioned, using DevSecOps, using that kind of process lowers the security costs, less technical debt for the developers, and happier teammates, right? And everybody would like that. All right. So with that being said, I have a diagram here that kind of shows you why not be more developer centric? When in our current process that we're seeing now is that we're using security tools around the stage of deployment, and we kind of just want to shift that left because we want to take care of security vulnerabilities earlier in the process, right? So testing just before deployment, why do that? Static testing and dynamic testing happen at the end of the delivery cycle. I think we can shift that left, right? So let's talk about advanced security, our product here at GitHub. So advanced security is a suite of security tools used to enable developers to identify security vulnerabilities in their code bases. So as you can see, that includes code scanning, secret scanning, Dependabot, security advisories, security policies, and dependency insights. And let's pretend that we have dependency reviews squeezed into this list as well. I'm sure you guys heard about this during the Universe talks. So this product dependency review is another fantastic tool that offers tighter integration of security by helping contributors understand dependency changes and their security impact at every pull request, right? So furthermore, we want to bring a native and automated experience when it comes to securing your code on GitHub. And it's very important that when we talk about application security, perhaps part of the challenge with application security today, as I mentioned before, is that it's pretty much like a security teams experience. And what we want to do at GitHub and to share around the world is to make this experience to be more dev-centric, right? So the developers who are the ones that are responsible for remediating and fixing these issues. We want developers to come to a single point to utilize security tools alongside all of the other software development initiatives that they're running inside their pipeline. So in this particular workshop, we're going to focus on exploring code scanning, secret scanning, and Dependabot. And when, Dependabot is two applications that we're going to explore, the security alerts and the security updates. So there you go. And another diagram here to show you. So here is a basic application security scenario. Here again, in this scenario, and some developer workflows that I've seen myself and other teammates as well, the usage of security analysis happens right before we're about to ship, okay? So once again, why not use these security tools earlier in the software development workflow, which could be alongside securing coding practice and quality code checks, right? So I've improved it right here. All right, so here we're shifting it left. Here's how it can be better. Instead of software dev teams and IT operations and security teams working independently, why not commit to sharing this responsibility of security and follow security guidelines in all lines of work, right? So this is where we want to be, to shift security left and have security integrated at the PR level. So just a little recap of what's going to happen during the workshop. So some questions that you should have in your head right now. How are we going to shift left with these advanced security features at our hands? And what we're going to do next in the next hour is enable these features as mentioned previously. Okay, so getting started, just want to make sure that everyone's all good. This is just like a health check slide. Are you logged into GitHub right now? Have you accepted an invitation to be a collaborator of the Universe Workshop organization? So just taking like a small breather right here to get everyone settled. And if you have any questions at all, please utilize the Slack channel. Right. So I'll just pause for like 30 seconds right now. Awesome. Alrighty. So hopefully everyone got like a chance to sip their coffee or their water or their tea. And let's get started on talking about our demo application. So if you have your repository and you're seeing it, there's like a couple of folders in there. You kind of see like, oh, it's a demo application. It has like many languages. So it's a simple gallery application with a handful of services. So as you can see, if you look in the front end folder, all of that is written in JavaScript. We have a couple of backend services written in Java, Go, and Python. And just to note, it's not required that you try to spin this up. Most of what we're doing will be in the browser, enabling secret scanning, Dependabot, and code scanning in the UI. And we're going to modify a couple of files to see some of the alerts. And just a little hint, there's a script folder, which contains a Python script that generates secrets, which will be handy in one of our exercises. So I'll be sure to mention that again once we're doing a deep dive with secret scanning. All right, so change the slide. So what's an easy way to do to improve team security? So if you have a moment, I'd like to get your thoughts on this question. Please post like any thoughts you may have about this question. Love to get your feedback. And let's just start off by giving a nice introduction to secret scanning. So some self-reflection questions for introspection. Have you pushed something to a repo and you know you shouldn't have, or who has seen someone commit or expose secrets to a repository? So who's ever been in a situation where you're working too fast, maybe you have 3 features to do and someone like your tech lead asks you to rotate the keys, you do so, but accidentally commit these credentials to production. So we all make mistakes, things happen. Love to share, see your share of stories in the Slack channel if you have any. So this is where secret scanning comes in. We use secret scanning to scan for known types of secrets to prevent fraudulent, deceitful use of accidentally committed secrets. So when you push to a public repository in GitHub, GitHub scans the content of the commits for secrets. If you switch a private repository to public, GitHub scans the entire repository for secrets. If you check a secret into a repository, anyone who has read access to the repository can use the secret to access the external service with your privileges. So for safety measures, we recommend storing secrets in a dedicated secure location outside of the repository for your project. And personally for me, in past previous experiences, I've worked with system engineers that could like, push those secrets to like a sandbox, like a secret sandbox, and make sure that it's safe. So making sure that you have like secure practices is like a really good thing to have. So when secret scanning detects a set of credentials, GitHub notifies the service provider who issued the secret. So the service provider validates the credentials and then decides whether they should revoke the secret, issue a new secret, or reach out to you directly, depending on what the risk is. So I've listed a resource in our repository. It's a long list of providers which can be found in our GitHub documentation. So for instance, one of our service providers is AWS, Strip, Atlassian, Azure, to name a few. Okay. So Dependabot. So Dependabot, for the purpose of this workshop, we're going to go over Dependabot alerts and security updates. So now that we talked about secret scanning, what about the dependencies that our projects rely on? Can you think of a time when you worked on a project that had a handful of vulnerable dependencies? So again, if you have any thoughts about this, we'll love to hear your story. So Dependabot security updates make it easier for you to fix vulnerable dependencies in your repository. So when you enable this feature during this workshop, when a Dependabot alert is raised for a vulnerable dependency, in the dependency graph of your repository, Dependabot will automatically trigger a pull request, which is pretty cool to do since this isn't done natively and there's no need to integrate this functionality into your CI pipeline. All right. So let's take a look at secret scanning and Dependabot in actions. We're going to go through the practical exercise at the very first one. So let me handle this maneuver of transferring the keynote to my browser. So let me do a new share of this. Can everyone see my screen? Thumbs up. We're good. Let's see. All right.
It looks like that's a yes.
That's a yes. Okay. I couldn't see like the green like highlight over the monitor, so all right. I get very insecure about that when I don't see it. All right. So I made my own copy of our workshop, right? DevSecOps automation with GHAS. So as you can see, there's a pattern, like you'll find a repository with DevSecOps GHAS with like your handle. So that's the repository that you should be using. And you should be an admin to your own repository. All right. So what I'm going to do is I'm going to go into the exercises right here. Our very first exercise is going to be with secret scanning. And so just to give you like a little overview, if you start with secret scanning all the way towards the bottom, we'll find like our next link to go to the next like section. So this section here is Dependabot. You go all the way to the bottom. Then we're here at code scanning. And then all the way to the bottom, we have some additional references that you can look at after the workshop. All right, so let me go back to secret scanning. All right, and I have a tile manager, so hopefully this would look great to you guys. So I'm going to have the instructions right here, and then I'm going to follow those instructions in this other window right here. All right, so let me go to the root. All right, so for practical exercise 1A, we're going to enable secret scanning. So let's go to the settings page right here. And in the settings page, you'll see a bunch of tabs over here. The one that we're mainly concerned about is like going to the security and analysis section. So right here. And here you'll see the configure security and analysis features. And as you can see, obviously, like we have 4 options to enable secret scanning, Dependabot security updates, Dependabot alerts, and dependency graph. I knew I read that backwards. So for this section, let's enable our secret scanning right there. Awesome. So as soon as you click that button, it'll go to disable, which we won't do. Okay, so let me read through these instructions. After a few minutes, the security tab in the repository will indicate that there are new security alerts. So let me refresh my browser for you. So if it doesn't happen automatically, you could like commit something simple into the README to trigger it. All right, so it looks like for me, I need to trigger it. So I'm going to put like a test text right here, and hopefully that'll do it. And it's okay for, in this case, to commit to the main branch of your repository. Let's see. Secret scanning alerts. Okay. All right, so this might take some time. I've actually created a solution repository. So this is something that I'd like to share with you all after the workshop. But what you're supposed to see at this point is, you know, a couple of secret scanning alerts over here. So the ones that it'll find are the Amazon AWS access key IDs. All right. So I'm gonna pause right here, get everyone to try and see if you can get those alerts to show. So I'll pause for a minute. If you have any questions, please post your questions on Slack.
So I guess we can just respond to some of the questions on Slack.
Okay, cool.
So Mike asked if secret scanning is an extra SKU. All of the advanced security stuff for open source is going to be available to everyone, and I think with one tiny exception, it should all be available to open source today. So if you've got public open source repos, you'll just have it. For enterprise customers, yeah, it's part of the advanced security SKU, which includes secret scanning, code scanning, and a few other bits that were on Chelsea's earlier slide that we are not going to cover today, but I would encourage you to look into if you're interested in that kind of thing.
All right, sounds good. Let's see. I'm going to refresh my page and see if we have anything. So as indicated by this little reminder, once like GitHub finds like those secrets, they'll send an email to you. If you are signed up for notifications of your own repository, you'll get that notification describing like all the key secrets that it found. All right. So looks like I might have like a little trouble here with my own repository. So good thing I have my solution repository to show you guys. So let's just move on to the next section right here, which is to introduce a test secret. So when developing test cases, it might be the case that secrets are introduced that cannot be abused when disclosed. Secret scanning will detect and alert on these secrets. So, so let's head over to the service, which is written in Java, the storage service. So in the source folder, we're going to go to the resources and commit a file for the development environment. Okay. So here we're going to generate some secrets. Let me go a step above and create application.dev properties. Dev properties. Okay. So you can either like copy and paste this key ID and secret key, but make sure to like probably modify like the 6th to last like character in there. Otherwise, you can go into the scripts folder that I talked about and generate a new set of key IDs, right? So I have my terminal open and I pointed to the scripts folder. And what we can do is run this script. Okay. And if you do plan to run this script, make sure that you have like the random string package installed. So make sure you pip install it, and yeah, make sure you have Python 3 installed as well. So those would be the key IDs and secret keys that I commit. And looks like I see in the chat that someone's secret scanning completed, which is awesome. Wish I could say the same for myself. I'll check on that later. So right now I'm about to commit this application.dev properties file. So if you're familiar with properties, there might be like a stage 1 and a production 1. So I'm going to commit this right now and let's determine if this secret pops up in our alerts. Okay. Hopefully it goes. Okay. Awesome. I'm happy. So it detected the ones that I expected earlier. So I'm going to wait for the one I just committed for about 20 seconds. All right. If it doesn't show, then we know that we committed it to some dev properties file. So it's all good. So I'll give everyone about 30 seconds to work on this step. All right, net 0 got the first 4. Awesome. Cool. So if yours only picked up 2, one thing that you can do is use that Python script to like generate a new one, just to like play around with it some more.
Have a look in that repo and see if I can figure out why it's only got 2.
Yeah, yeah. Right. All right. Yeah. So yeah, I didn't get a good look at this, but yeah, application.dev properties, it picked up those 2, and then the one from application.properties. So my bad on that. Let's move on to excluding files from secret scanning. Sorry. Can't say that. I don't know why. So while we can close a detected secret as being used in the test, we can also configure secret scanning to exclude files from being scanned. So as you can see, if we go back to our repository in the root, let's go into the .github folder. And as you can see, we've already created the secret scanning YAML, right? So what you can do in here is exclude files from secret scanning. So already by default, or what I've added a couple of days ago, or probably yesterday night, I added the README since we don't really need to scan secrets in there. It's pretty obvious that we're not going to do that in there. But I mean, if you do like commit a secret in there, it'll detect it if you remove this from the path ignore, along with the exercises as well. So if you're familiar with the filters that are being used, then this is something that you can do. You can use the star, which means like, hey, anything under this folder, we're not gonna look into, right? So as with the application.dev properties that we've committed, if you look into the solution, or if you don't want to look at the solution, what we can do is, exclude that path, right? So that's what I'm going to do. I'm going to copy and paste this so I don't make a mistake when I type. So let me do that. And you can also exclude the test folder. So let's go ahead and do that as well, right? Commit that to my secret scanning YAML. Okay. Okay, so it managed to ignore the application.dev properties file, which is what we expected, right? And for the third step, test the pattern by adding another secret or to the file application.dev properties. So for example, changing the secret key by manipulating a character in the existing one or using the Python script. I'm going to leave this step to you guys. I'm just going to ignore this piece since I like to move on. But love to get your feedback on this little exercise right here. All right. So let's move on to the last step, which is managing access to alerts. So due to the nature of secrets, the alerts are only visible to organization and repository admins. Access to other members and teams can be given in the security analysis setting. So if we go to the security analysis settings again, we should see this access to alerts section right here. So this pertains to Dependabot and secret scanning. And as mentioned, by default, admins have this visibility. But if you want to enable this for someone else, they need to have right access in order to see those Dependabot and security alert, secret scanning alerts as well. So if you have a buddy with you during this workshop, go ahead and give this a try by adding them to your repository and then finding their name in this section right here where it says search for people or teams. Okay, so I'll give about probably 40 seconds for this, 40 seconds to a minute on this, just in case anyone has a buddy. So, and a chance for me to drink water. So. All right, so let's move on to the next section, which is Dependabot. So let's see, I have a couple of slides that I'd love to share with you all. So let me go back here and oops, I touched something I didn't supposed to touch. Okay, so can everyone see my slides? Can you give a thumbs up if you see it? Mario or John? Sounds good? All right, cool.
Yes.
All right. All right, so that was practical exercise 1 with secret scanning. And I have a cool recap slide for you, just to do a health check. All right, so great job on the first exercise if you're able to complete it. So in this case, we're able to enable secret scanning. We're able to view and manage the results, modify its respective configuration file, which is the secret scanning YAML that we discovered. So there's some stretch goals. And if you look into the additional references markdown, you'll be able to see the GraphQL API and some other APIs that we have listed there, such as code scanning. So, all right. So let me get settled here. All right. So how do we find vulnerabilities in the code that we write? I think I've jumped ahead in my in my slide for a second. Yeah, I jumped way ahead. Oops. Okay. So actually, I did a mess up right here. We're supposed to go over Dependabot after this instead of showing you this recap slide. My bad. It's in the it's like 8 o'clock here, so still, I guess, trying to wake up. My bad. So let me exit out of this and let's just jump into the next section. Sorry, y'all. How did that make that mistake? All right, sorry. So let's just jump ahead with Dependabot. All right, so let's go through there. So enabling Dependabot alerts. So if you're already on the security analysis section already, the settings, I mean, then you can enable dependency graph, Dependabot alerts, and security updates. So let's do that right now. That's an easy step to do. So let's do that. Okay, awesome sauce. So, okay, so as soon as you enable these features, you should already see like a bump in like your security alerts already. So let's look into there. So right now you should see 6 Dependabot alerts, and it found each of these services. So the front end service, the authentication service, and the gallery service and storage service right here. All right. And what you can do is see the dependency graph in the Insights tab. So if you take a look, you go to the dependency graph, and you'll see like all your dependencies listed here, which is pretty awesome, right? Okay, so I'll give about 30 seconds to everyone get on the same page right here. Okay, so in this section, viewing and managing results. So after a few minutes, as I said, you should be able to see like some of those security alerts. So we have a note right here. If you're not able to see it, you can trigger an alert by modifying the requirements text file. So if you're not familiar with requirements, that is used to use for Python projects. So you can put your dependencies in that list and pip install it, right? So let's go into the authentication service. So if you want to do it, you can modify any of these dependency versions to a vulnerable version. So let's see if I can find Django. Django is not in here. I think maybe Django 2.2.13 is one. So I'm going to put that in there. All right. 2.2.13. if you want to do a little bit of research to find like a vulnerable version, you can do so right now. Okay. So when that is done, head over to the next section, enabling Dependabot security updates. So as mentioned in our slides, Dependabot can automatically create PRs to upgrade vulnerable dependencies to a non-vulnerable version. So I've already enabled this for myself, but if you haven't already, take the time to enable Dependabot security updates in the security analysis settings. All right. So as you can see, you should be able to see a couple of PRs in your pull request tab that kind of bump up the version, which is awesome. So here, as you can see, we have a PR to bump up Axios from 0.18.0 to 0.18.1. So I'll pause right here for a couple of seconds. Okay, so right now, if you're able to see PRs for your dependencies, awesome. The next thing that we want to do is configure the Dependabot security updates. So, so to just successfully integrate the security updates into the software development lifecycle, it is possible to configure various aspects such as when security PRs are created, what labels are assigned to enable filtering options, who is assigned to the PR, who should review it, and specifying which dependencies are updated and how they're updated. So what we can do right now is go to the hidden GitHub folder and create a Dependabot YAML. So let's do that. Awesome. So what we want to do here is look for dependency information in the directory authentication service. And then a list of steps right here too. Scheduling daily security updates, prefix to commit message with the package manager pip, assign the PR to yourself or a buddy of yours that is in a workshop with you as a reviewer. Add the custom label triage required to enable filtering of the PRs and make sure the label exists by adding it to the labels section of your repository. So, so let's go ahead and do that. I'm going to just like skip ahead at the risk of like mistyping some things. So in my solutions repository, let me find that, open up a new tab. What your Dependabot YAML should look like is something like this. So as a part of the workshop instructions, we want to prefix the commit message with the package manager pip. We want to look into the dependency information in directory authentication service. We want to schedule this daily to look at dependency vulnerabilities, if any. We want to put the labels triage required. If you want to, you can create your own label as well. I'm going to assign it to myself, but if a buddy with you, assign it to them. We have also a reviewer's key right here. I put non-existing, and then the commit message, prefix it with pip, right? So your solution to this part of the exercise should look like this. And let's see. I don't think for this repository of mine, I have any labels. So if you don't have any labels, it's possible that it could throw like an error or it doesn't show. Oops. Let me just test out this one. Put security labels in there. Okay. And that is because we're in the wrong organization. Sorry about that. So make sure for this step that if you are trying to create labels, that you don't immediately copy and paste that. That's a typo. That you put GitHub Universe Workshops. So my bad on that. But this is where you would create the new labels right here. It's simple and easy. So let's see, I had here triage required. So let me make a label for that here. And then you can pick the color, your favorite color, or generate a random color and create that label. Okay, so I'm going to pause here for a couple of seconds for everyone to catch up and get the labels situated and creating the Dependabot YAML. So, all right. And there's also a solution in the workshop markdown as well. So.
There's a question in the channel about what time it runs at. And I think that this is actually a little bit subtle. So I believe that it will run more frequently than that. So it will provide you updates for things that are out of date as soon as it can. And the time that you put in that config file tells it when should it check the registry to see if there's new versions available. So you should, even if you set it to 5 a.m., you should start getting PRs and alerts now. But if, let's say that, you know, in 2 hours, someone releases a new version of Django with some security vulnerabilities fixed, then that time says when's the next time that we'll actually check the registry. And so that will happen overnight. So I guess if you have like a known schedule where things are published internally, you may want to set that, or if you just want most of your updates to come in the middle of the night.
Cool, awesome. I'm going to wait for a couple of seconds till we hit the 45 mark, and then I'll begin like the next section for this.
Do people have dependable alerts? Have they got through the, do you have pull requests?
Let's see.
Give us a thumbs up in the channel if you do. Awesome.
All right, some people. All right, awesome. Cool. Cool. Someone posted a YAML. Looks like it's assigned to me. I have things to fix. Awesome. All right. So I'm going to start the next section. I'm actually just going to refer back to the recap that I showed earlier. So this would be the proper time to show it. So let's do a new screen share. Can y'all see it? John, are we good? Thumbs up.
Yes.
Awesome. Mario, awesome. Sweet. All right. So now it's the actual recapping. So if you're able to modify the secret scanning YAML, the Dependabot YAML, and they're able to see the secret alerts and the Dependabot alerts, then awesome. So this is like the awesome like automated native experience that we want developers to have. This is something that you can do in probably not in 5 minutes, but probably like 15 to 20 minutes of like your time to have like a really big impact on security. So it's like very easy and awesome. So so how do we define vulnerabilities in the code that we write? So I'm alluring to the code scanning part of this. So let's go to the next section right here. So code scanning. So we've gone over how to scan secrets. We've found vulnerable dependencies along the way. So what about our code? So suppose you're in a sprint and you have 3 features to develop, or how many features you want to develop. You develop these features and submit PRs. With code scanning enabled, you can actually scan your code and your pull request and see any securities introduced, rather than seeing those securities introduced later on. So it's awesome to have code scanning integrated into GitHub because developers like yourself can quickly and automatically analyze the code in the GitHub repository to find security vulnerabilities and coding errors. So in addition to the native experience, CodeQL is a key ingredient in the secret sauce behind code scanning that makes the tool truly unique and powerful. So you can use code scanning to find, triage, and prioritize fixes for existing problems in your code. You can schedule scans for specific days and times, or you can trigger scans when a specific event occurs in a repository, such as a push. So we'll get to explore all of that in our exercise soon. So if code scanning finds a potential vulnerability or an error in your code, GitHub displays an alert in the repository. So as you've seen, like in this screenshot, we have Dependabot alerts and then code scanning alerts and then secret scanning alerts. So we have a section for each, as you've seen already. So after you fix the code that triggered the alert, GitHub closes the alert, and we have more information in the resources section of the README to find out more about code scanning on your own time. There's like really good documentation on what code scanning is all about, configuring code scanning, and all that jazz. So we get to explore all of that in this workshop now. So let's enable code scanning. All right. So let me get out of this keynote again, and I'm going to share my other screen. Okay. So let's go to the next section here. All the way in the bottom, you'll find that click here link to navigate you to the code scanning section. And I'm going to use my personal repository again and not the solutions one. So this will be practical exercise 2. And basically what we're going to do is go into the security tab. And in the security tab, you'll see the security overview section, which lists all the GHAS features here, along with code scanning alerts. Here, you'll see setup code scanning. We want to click that button. Okay. So when you click that button, you'll be introduced to this screen here called Get Started with Code Scanning. We have our very own CodeQL analysis, but we also have like security analysis tools from the marketplace. So not only do we have like our very own CodeQL analysis tool, you can choose like other ones, right? We have Codacity security scan. We have the GHAS tool from Checkmarks. So we're very flexible in terms of like, the security tools that you want to push into your workflow, right? So For the purposes of this workshop, though, we're going to go with this code analysis. We're going to set up the workflow for that. And so by default, we have a workflow populated with some values already, which is kind of cool, right? So we don't have to like type and make mistakes in the YAML like me. So the first thing that you'll notice is the name of your workflow. It's simply called CodeQL. You can easily modify this. It's a string. The next section here are the events. So in the events, we have the push event, we have the pull request event, and we even have a schedule. So the neat thing about this cron job is that when you commit a CodeQL analysis file, like here in the UI, if you do it again in a different repository, this cron job is randomly generated. So you'll see for mine, the schedule will be 10:19 UTC on a Sunday. So when you see this on your own, it's probably different from my cron schedule, right? Okay, so what we're gonna do by default is enable code scanning on push, pull request, and on this schedule. Okay, so the next section here is the jobs section. So we've defined a job called analyze. We named it analyze here. So for this particular job, when we're doing CodeQL analysis, by default, we have here Ubuntu. You can run this workflow file, for instance, on Windows if you're dealing with like a C# project. You can also modify this to be using Mac. So we have options here. By default, in this case, it would be Ubuntu. We have a strategy key right here, a fail fast option, a matrix.language option. So the neat thing about this is that GitHub automatically detects like the languages that are being used in your repository. So in this case, it's Go, Java, JavaScript, and Python. And in this section, these are the steps. So in order to perform CodeQL analysis, it's a series of steps that we need to take. First, we need to check out the repository, right? After that step, we want to initialize the CodeQL runner. So here we're using like the CodeQL action with these languages that are defined in our matrix language, which was right here. Right, and then after that, we have like an auto build step. So this step is like meant for like compiled languages like C, C#, and Java. We don't really need this step for like the dynamic languages such as like JavaScript and Python, since we're going to auto install like those dependencies that are defined in a repository. So we don't need that. And then the last step right here is to perform the CodeQL analysis, right? So what you'll notice, like after we commit this workflow file, you'll see like the jobs running in parallel for each language. So let me commit this file, and I'll pause for a couple of seconds to get everyone on the same page. Okay, so when you commit that file, it'll direct you to the path in which that file was created. So I'll give everyone a minute to do that. Oops. So let's head into the Actions tab right here. So as you can see, when we committed that file, it automatically triggered to run an action, and that's because we pushed, right? And as you can see, it ran those jobs for each of Go, Java, JavaScript, and Python in parallel. So if you go through these logs, you'll be able to see like the steps that we defined, right? Checking out the repository, initializing CodeQL, the auto build step, even if it's necessary, right? And you can go through these and look at the logs. So if you look into perform CodeQL analysis, you'll see like the series of steps inside like the runner itself going through these steps, such as extracting Go, finalizing Go, doing the analysis of the database that's going on in the backend, right? And then after that happens, doing the normal like post checkout and completing the job. Okay. So I'm going to, so it kind of depends on like where everyone's at. Mine will complete probably in about a minute from now. So once everyone's like workflow kind of finishes, I'll go on to the next section. But as you can see, something went wrong with the Java build, right? And we're going to explore that. So in Java, you'll see like the auto build step failed. And JavaScript seems fine. And then Python, it's still running, performing CodeQL analysis. So I'll give like another minute or two for you to explore like the logs and getting this action to finish. All right, I'll give a couple of seconds more. At the top of the hour, I'll start working through the next section here, which is customizing the build process in the CodeQL workflow. Okay. So it seems like for one person, like the Python analysis is taking a long time. So let's try to move on to the next section, which is configuring the build. I'm sure it'll complete within the next minute or so. So let's move on to this section here. So as you can already tell, the Java workflow kind of failed, right? So what we're going to do is modify the workflow so that we can resolve this problem. Okay. So if you look into the logs for it, let's see if it gives us any information. All right. So it says it's trying to pick up the Java 2 options, and then we reach like some error, right? We need the correct Java JDK. So let's go back into the workflow file and modify that. Okay. Okay, so what you can do now, so the solution to this is to actually set up the Java JDK, right? And we have an action for that called setup Java at this version, right? Java version 11. So you can either type it, or if you don't want to type it, you can just, copy and paste. Okay, so what we're going to do, we're going to add that step right after initializing CodeQL. So, and if you want, you can remove some of these comments if you think it's just clouding up your space. I'll try to remove some of these. Okay, remove this so it's all clean. And let's add that JDK step right here. All right, and make the spacing okay. Cool. All right, and go ahead and commit that file and see how the action runs again. So commit to the main branch. And so when you start this commit or submit it, another action will run again. So I'll give a couple more minutes for everyone to complete that step and then have like this action complete as well. And if you haven't noticed, if you look into the security tab, you can see already that we've found some vulnerabilities when it comes to code scanning. All right, so at this point, we're going to make sure that the Java build actually is successful. And then after that, we're going to explore some of these results right here. So I'll give a few moments. All right, so it seems like my Java build passed. I'd like to know how everyone's doing. Just a small health check. Looks like my analysis for Python is still running. Okay. Gotcha. Okay. So let's have that still running for a couple of minutes. Let's just dive into the security alerts that we have. Okay. So far for me, I have 6 of them. So let's look into the first one right here. And let me expand my screen. Okay. So this one right here is a disabled Spring CSRF protection. It detected that from the Java class web security config. So as you can see here, it highlighted where it found that vulnerability, right? We also have in this section here, like a little help file, RQ help file, as it's called in the backend, where it kind of describes like the recommendation, like what to do when it detects like a CSRF vulnerability like this. So part of the exercise is if you're familiar with like CSRF, or you kind of know like based on like what this application is doing, we rely on the bearer tokens to like authenticate. So in your own thoughts, like, do you think that this is a false positive or you think it's a true positive? So this is something that we can discuss in the Slack channel, like whether or not this is something that we should fix or something that we should just dismiss, right? So hopefully that's enough of a hint to give you about this particular vulnerability. Let's look at another one. So in each of these, it'll highlight like the vulnerability and it'll give you like some explanation of it and the recommended path to go about it, right? And which is really neat because you don't have to like, you know, search on Google, like what is this or anything. You can just like look at it here natively in GitHub and look at an example of that vulnerability, which is cool. And along with that, we have like a bunch of references too. So it saves you the trouble of like searching for these things, right? So you can look more into like the CWE, the OWASP guidance files and all that. And yeah, just a bunch of other things that are useful in determining whether or not to fix this vulnerability, right? So hopefully by now, the second action has completed. It has, and it took, as you can see, it took 5 minutes and 1 second. Yes, awesome. Hopefully it's completed for you guys as well. So triaging a result in the PR. All right, so let's look into this step right here. The default workflow configuration enables code scanning on PRs. Follow the next steps to see it in action. So right here, we want to introduce an alert. Okay, this is a simple one where we're using the eval on the JavaScript, and we're going to evaluate this code. Now this code, it could be anything, right? It could be like some XSS. So let's get started on that. You want to create a PR out of this too. So I have one ready right here. Basically, you want to add like this snippet of code to this .has code and this .has state in the authorization callback.view. You can also add this eval anywhere in the file that makes sense, right? So you can add it to the mounted method. All right. So I'll give you a couple of seconds to commit that. And if you've noticed already, we have like a stretch exercise, which is like a bonus exercise. If you're really ahead of the game and you want to like complete these, that's awesome. This one right here talks about like using the context and expressions to modify the JDK step that we have. So how would you modify the build such that the JDK step runs only for Java? So this one gives you, I'll give you a hint, has something to do with the context and expressions. We have documentation on that, I believe, in our resources. So if you know how to use that in actions, then you can simplify this workflow file. All right. I'll pause for about a minute or two. All right, so when you make that change and make a pull request, another action will spin up because in the work profile, if you remember, we've added the pull request event so that we can trigger an action, right? So once again, we have all these languages running in parallel, all the analysis for it. And I'll give a couple of seconds for everyone to have their actions run. So another 3 to 5 minutes. But what you should see is another alert popping up in your security tab. And if you were able to complete this stretch exercise, what you should see is, if you look into the solution, you should only see like the setup JDK step run only for Java. So right now, like I didn't modify that, and hopefully the setup JDK step shows for Go, JavaScript, and Python. So if you use context and expressions like this, if matrix.language equals Java, then only that step only shows for the Java run. Okay. Those are really long logs. So I'll pause right here for a couple of minutes.
If you're only setting up the JDK, it's probably not a big deal if this runs for all of the steps. But if you have a lot of different languages and some of your builds take a long time, it can be a really big saving to turn off steps that you just don't need for some of the jobs.
All right, so looks like for me, the Python analysis completed. Therefore, like the entire action is completed. So let's look into our PR. So as you can see, let's go back. You can see like the analysis for each of the languages have completed, right? But then over here in code scanning results, we get the big X, right? So if you click on details, and let me expand my screen, we see that we have an error right here. And it says it's a code injection. So that's basically what we did. We added that eval on the code, this.code. And we can show more details. And it'll, once again, it'll show you like the highlighted code right here, what we just added, and then some explanation about it. Okay. So this is pretty cool because we can see all the alerts that are introduced in the PR. And it's a very simple UI in here. And let's see, show more details. Did I go through that already? All right, so it points to the same file. And then we also have the option here to say, hey, is it a false positive? Is it used in tests? Or you won't fix it, right? So usually if this happened in a test folder, right? I find that you can just, use this option right here, obviously, or you won't fix it. It's not like a huge deal in your repository. So you have the option to like do something about this alert at this page. Okay. So here, this is the path. So it says, this is some source in which it started. It starts here when we're declaring params to this URL search params, and it has window.location as a parameter. And it goes through the steps and how it got to like eval.this.code. So this is the data flow shown here in the UI. And as you can see, we've labeled this first step as the source, and we labeled the last step here as the sink. All right. And it even says here, it's a user provided value, flows to here, and is interpreted as code. So yeah, this is a pretty neat tool. If you want to like dig into like, how do we find that? You can just like go through these paths right here. All right. So hopefully everyone has completed this exercise. We're going to move on to the recap slide that I have for you, and then we're going to go to the last exercise of this workshop. So let me switch gears for a moment. Dark mode troubles. All right. All right, let me play this. Can everyone see my screen, or is it gray? I think it might be gray. It's gray. Okay. All right. That was a fail. Let me go back. Okay, good. We're good here. All right. Oh, the two.
Yeah, I think we've got presented view.
Okay.
There you go. Good.
Awesome. All right. Keynote's not my thing. I'm more of like a Google Slides person, so bear with me. All right, so this is the recap slide for exercise 2. Hope you're able to enable code scanning and all that jazz, fixing the build, introducing an alert in a PR, finding any false positives, right? So enabling code scanning, this is something that you can do easily, right? This is something that you can do quickly to have an impact on security. And let's see, can I change slides from here? Not sure if I can. Okay, so a common question that we get is, should we block merges, right? So the idea with using advanced security is to enable you, the developer, to take the best approach when it comes to securing your code. So this isn't a tool that's meant to slow you down in your development workflow. Rather, it's a tool that should help you resolve vulnerabilities the earliest it comes up, which usually can be prevented in the PR. So as we've seen previously. So knowing that, doesn't it sound better knowing you have these security tools at your disposal and it's you that can make a good choice, having a great impact on securing your code, right? So if you think it's a good idea to block the merges because you want to like fix those vulnerabilities, that's awesome. But we're not making, forcing you to do that. We want to be more developer centric. We want to see more developers communicating with the security teams communicating with their developers. We want to see that collaboration going on, making this like, a responsible thing to do when it comes to like securing code, right? So with that being said, let's move on to the next section. How do we refine code analysis to address false positives or catch more vulnerabilities? So let's modify our code analysis configuration. This is the last practical exercise of the workshop. So let's get on with it. All right, out of Keynote mode. And I'm going to share my screen, the exercise again. All right, so down to practical exercise 3. And let me open up a different workshop. Hold on, I'm just going to copy this thing. Oops. Have 2 windows open for you like this. All right. So by default, CodeQL uses a selection of queries that provide high quality security results. However, you can change this behavior by defining a custom CodeQL config, right? So, so what you can do is, one thing that you can do easily is if you don't want to have that custom CodeQL config now, you can modify your existing one, your CodeQL analysis YAML, and add in a queries key that kind of tells the analysis tool, hey, like I want to run this security and quality query suite. So there's 2 available. There's security extended, right? And security and quality, which is security extended plus some other reliability and maintainability queries. So these query sets that are optional, they just like pinpoint like the low severity alerts. So what you can do is add that key under here and define like those query suites, right? Yeah, so you can do that. But the option here in the workshop instructions, let's do it this way. So what we're going to do is create this file called CodeQL config in the GitHub folder. Okay, so you can go to add file, create a new file. You can create a new folder like that, and then putting a /, and that creates that new folder. And then let's create that YAML. Okay. So what you're going to do is basically you're going to add like the query suites here, right? So I'm just going to copy this. And I'm going to add the security and quality suite in the query section of this YAML. Okay, so that is another way of using that suite. Alrighty. So that's the first thing that we want to do is creating this file. And then what we want to do is tell our main configuration here that we're going to use that file, right? So let's do that. Okay. So uses language, we're going to put it right there. So let's see. We're going to put this key value called config file. And then we're going to put that path to the configuration, the custom configuration that we just made. into that as the value. Okay, cool beans. So once you have that, go ahead and commit that file, commit those changes. Okay. So your YAML at this point should look something like this. Okay, and I'm just going to make sure that, yeah, all right, that looks good. Okay, so I'll give everyone about 30 to 40 seconds to get that done, and I'll move on. Okay, so let's see what's going on. We have a new action. So what you can do is, since we created that custom config file and then we modified the code co-analysis file, you can cancel an action so that we're waiting on the latest one instead, right? Also time to save some minutes, right, in the organization, so not killing any more minutes. And let's see where this is at. All right, so when it's completed, let me know if you all found a new security alert that was introduced. Let's move on to the next section since we have less than 30 minutes of our workshop, and I want to get around to any questions that you may have towards the end. So let's jump into creating our own custom queries file or folder. So in this section, we want to target languages and some of the query suites of a language, right? So yes, we can exclude the rule that caused the false positive in our Java project by doing this. So what you want to do is you want to create a code scanning query suite under a folder called custom queries or something, a different name if you want. And what we want to do is remove or exclude that ID that caused that false positive in our Java project or Java class. So to save some time, I'm going to open up the solutions repo that I have instead. GHAS user. Doing this in the most inefficient way. So right here, I have a custom queries folder. And in that folder, you first want to create this code scanning query suite that has these values here. All right. So we're pinpointing the code scanning suite for each of these languages that we have in a repository. And we also want to use the exclude key right here. And so the ID that we want to exclude is called Spring Disabled CSRF protection, right?
So I will say quickly that the query suites are more of an advanced, excuse me, advanced option. Usually the default ones are pretty good, but if you have, let's say that you've got a particular rule and it's just not applicable for the threat model of whatever your project is or your code base, and everything you're getting through it is a false positive, and you can say, well, I can see why some people might care about this, but we don't. This is a good way to turn it off rather than having to go through and hit dismiss a bunch of times.
Sweet. So once you define this code scanning query suite file, you want to make sure that we actually utilize this code scanning file by going back into that custom code config. So let me show that to you real quickly, like this. So once you have that defined, you can define the path for it in this queries key. And then later on, if you want to complete like the stretch exercise 4, you'll do a similar thing where you add in a custom query. So that is something that you can do after this workshop. So this will set you up for like the next security workshop. So hopefully you can get a feel for it now before you enter that workshop. So yes. So the key thing here is you can create a custom code file right here. And then you can reference like a folder that has like those custom queries, right? So in my repository, let's go back. My custom queries folder looks something like this. Oops. Excuse me. So you have the code scanning suite, and then if you complete that stretch exercise 4, 2 things that you need to define like the custom query, and then you need to define a QL pack. So we listed those steps here if you want to try that out. All right, so I'll give everyone until the 40 mark to complete these steps. All right, so I hope everyone had a chance to complete those last steps for exercise 3. And if you made it to the stretch exercise 4, that's pretty amazing. That would set you up for success for the next security workshop. I just want to share this recap slide. As I said, hopefully you completed all these steps. So the point of configuring or making a custom configuration file for CodeQL analysis is so that you can tune your results that better fit your needs for your repository, right? It's a good way to exclude IDs if you want to remove false positives. So you can handle it that way, or you can actually make like a code change to that and remove like that line, and we'll call it a day. That's awesome. But yeah, no one size fits all with security. We just wanted to be able to give you that option to fine tune your results and, you know, add any additional queries once you become familiar with like the CodeQL analysis runner. So with that being said, we have a couple more slides until I want to get into the QA section. So which checks should we run? So this is another common question that we get. So I know that we've introduced other query suites such as security extended or security and quality, which should search for those low severity alerts such as, hey, did I define a variable and I didn't use it? Did I define or create like an import some package and I didn't use it, right? So those types of alerts. So when it comes to this question, which checks should we run? The bigger picture is to focus on the rules that matter at large. So what are the checks that have the greatest impact? So once again, this isn't, you know, a tool to slow you down. It isn't a tool that should create fatigue, or rather alert fatigue, because we all know that we're trying to survive this pandemic. We don't want to experience any more fatigue already than we have. So do what matters most is the bigger picture. Try to be more dev-centric. Talk to your community about these security alerts, right? So what have we learned so far? So within an hour, we remediated secrets and vulnerabilities. We reviewed code scanning alerts. We've enabled additional queries and tried to filter false positives. So with that being said, I'd love to get your feedback on this workshop. So how do you feel about secret scanning, Dependabot, and code scanning so far? And a call to action. So I hope you learned a lot during this workshop. I'd love for you to try these GHAS features on your own repository. Another thing that you can do is to collaborate with security, you know, make the most out of collaborating with security teams, publishing your own security advisories to notify users of your own open source project. Reach out to us if you want to. CodeQL is an open source, and any contributions you make helps secure the software we rely on. We have like in our documentation, you'll find like how to contribute to CodeQL itself. And then lastly, consider shifting left, right? Embrace catching vulnerabilities earlier in your development workflow. And yeah, I hope everyone got a chance to like learn something new today. And with that, if you have any questions, I'd love to hear them in the Slack channel. We got, let's see, 15 to 16 minutes of Q&A. There you go.
Hey, Chelsea, someone just asked a question. Darren asked, if I'm the admin for an enterprise account, is there a way to get a summary of alerts for all the repos in the account?
Yes, so one thing that we're coming out with is called Security Center. This is the feature that will come out sometime next year, where you get to view all the alerts for all the repos in your account.
So Security Center is currently in alpha. So there's a couple of people who've been given access. And I'll drop the public roadmap item in the chat so you can all keep track of progress on it.
Someone asked, can we get access to the Security Center Alpha?
John, you want to take on that one? I don't know, like the full process of getting that enabled for somebody.
So if you're on Enterprise Cloud, then speak to, if you have a sales or services rep, reach out to them and they may be able to help you out with it. I think they are limiting access a little bit at the moment, but reach out and do their best.
One thing that I can do after this workshop is make the solutions repository public so that you can make sure that we're all on the same page when it comes to like all the files that we modified. So I'll make that repository public after this workshop is done. So.
Magno Logan asked, any recommendations on creating assertive custom queries with CodeQL, and how does it compare to SemGrep? Any plans to have that added into the workflow as well?
Could you clarify what you mean by assertive? I'm not completely familiar with it in that context. Also Google searching it, so so the default security set that we have should be pretty low false positives. We monitor fixed rates for all of the queries in that set on open source. And if stuff is not getting addressed by developers, then it's flagged to the teams and they reduce it. Once you go onto the security and extended and security and quality, those are by definition a little bit more noisy. Some of them are things that we just haven't been able to figure out a really good way of doing without a bit of noise, often because it's so dependent on the project in question. We have a number of different research type efforts to do things to try and look at like the quality of results. We're looking at a lot of like machine learning stuff and that kind of thing, but that is all very much like a little bit of a way out. Yeah, the best way I've seen of managing this is to basically start with a small security focus set and then add additional rules with the buy-in from the dev team. So if everyone agrees that we're going to follow a particular coding standard, And there's certain things, I mean, like use of eval is a good one. A lot of teams will just say we're never going to use that, and it's very easy to enforce like a more concrete standard like that. Doing all of the analysis to see is this definitely wired up to user input creates a little bit more of an analysis challenge, shall we say. So if you can get the buy-in on these kinds of standards, that's really effective. But yeah, start with the small set and go from there. So there's a question from Chris. Is the PR page the only place to see the execution path? No, you should be able to see it if you go to the security tab as well and navigate to any of the alerts. There's an option to see the path there. Yep. Not every query has a path. So most of the security related ones, obviously like user controlled value or user inputs are a big part of those vulnerabilities. And so they generally have a path. There's a few, and especially if you turn on the quality ones, where it's a more local check. And so it just shows you the single location. Yeah, that's a simpler way of putting it.
Yeah, let me share my screen for a moment. So if I click on this client-side cross-scripting alert, then you should be able to find that path here in this section. So yeah. And usually from the PR, it'll direct you to this, so. Cool. Yes, the slides will be available later in the videos. All right, so it looks like we have 5 more minutes. If you want to post like any questions or feedback you may have, you can do so now. If you have any thoughts about like any of the features that you've seen today, it'd be really nice to like get more feedback from you. I know a couple of people say that it's really cool. Thank you for being here once again. Glad to have shown you some parts of GitHub Advanced Security.
It looks like there's another question here. Net Zero is asking, if I am an open source project that forks other people's projects and scans them with CodeQL, when will I start getting bottlenecked? Yeah.
I think as long as your forks are public, it'll just be your regular actions limitations. So I think that there may be a per org concurrent actions limit. If you do 6,000 with a script, you'll probably hit some alarms, and you may get throttled. I think we're generally happy to raise that for people who have a sensible use case. So if that does happen, then reach out to the people in Security Lab, and they are always happy to help with anyone who wants to use any of this to improve security on open source. But yeah, it should be doable, I think. In general, forks work a little bit differently for actions to try and avoid you from accidentally running them when you didn't realize you had workflows and stuff like that. So I think you may also have to click and enable workflows for this fork, depending on whether they have an existing config or not.
Yeah, I think Net Zero is also asking about GraphQL, which I don't think is in the scope of this talk.
So we have, we do have some APIs for code scanning. I'm not sure if they have a GraphQL API for code scanning yet. Let me double check on that. I know we definitely have one for dependencies. And in one of the extensions, there's a stretch goal to try and use that to get some dependency information back with the API. Yeah, let me look up the code scanning one.
It looks like we might not have that yet, but if we figure out more information about it, we'll be sure to post that into the Slack channel. So I think we're coming up to time. It's just 10 more seconds, so.
So in general, our approach with APIs for new products is to start with them being pretty minimal. We know that it's really difficult if we give people features in an API and then they change or are removed. So they're starting small and they are being actively worked on by the team, and so they'll continue to grow with new releases.
Alrighty, sweet. So we're up to time. It's a wrap. Once again, thank you for joining us. The videos will be available later as well as the slides. So we'll have that you guys ready for you to use in view. So yeah, happy Friday and hope you have a good rest of the day today. Thanks. Peace.
Thanks, everyone.